All right, so in this video, we're going to be factoring quadratics when the term is not a 1. So for number 1, we're given over here factor 3x squared minus 8x plus 4. All right, so for this quadratic, our a term is a 3, the b term is a negative 8, and the c term is a positive 4. And there's a condition that must be met to factor this quadratic over here. You want to get two numbers and multiply to AC. And at the same time, these same two numbers have to add to your b term. All right, so that's what the condition is for every quadratic if you want to factor it, and the a term is not a 1. So in this quadratic over here for number 1, we're given that the a term is a 3 and the c term is a 4. So you want to get two numbers and multiply your AC term, and the AC term means 3 times 4, and that is a 12. All right, so and then at the same time, they add to your b term, and the b term over here is a negative 8. Okay, so it might take some time to get these two numbers, but once you get them eventually, you write them here, which they both it should be a negative 6 and a negative 2. All right, because negative 6 plus negative 2 is a negative 8, and at the same time, negative 6 times negative 2 is a positive 12. So once you get these two numbers, would you just factor it up into x minus 6 times x minus 2? All right, so this would have been valid if the a term was a 1, but since the a term is not a 1, this is not going to be a valid thing to write. So let's erase that. All right, so instead, what you want to do is bring down the first term as is. We have a 3x squared. And then break up your middle term, which is a negative 8x. Break it up into these two factors over here, which we have a negative 6x and we have a negative 2x. Okay, and then bring down the last term also as is, which is a positive 4. Okay, so all we did, we brought down the first term as is and the last term also down as is, but the middle term broke up into our two factors, which are negative 6 and negative 2. Now, does it matter which one comes first? Meaning, could we have written it as 3x squared, and then minus 2x, and then minus 6x plus 4? Okay, the answer is yes. This would have also been a valid breakup of your bx term. But the reason why I put it as a negative 6x minus 2x is because 6 is more compatible with 3, and 2 is more compatible with 4, right? So this number, 6, is compatible with the ax squared term, and the negative 2 is compatible with the c term. So both ways should work out well, but the way that I have it over here works out better because these two terms have a common factor of 3, and these two terms have a common factor of 2. All right, so which takes us to step number 2. If you want to factor out the GCF between the first two terms, 3x squared and negative 6x both have a common factor numerically of 3 and algebraically of x. All right, so and 3x times what gives you a 3x squared? 3x times x does. 3x times what gives you a negative 6x? 3x times negative 2 gives you a negative 6x. So all we did, we factored out the common factor between these two terms, which was a 3x, and we wrote down within our factor what's left over. That's pretty much the opposite of distribution. Because if you were to distribute this, 3x times x does in fact give you a 3x squared, and 3x times negative 2 does give you a negative 6x. And the same thing applies for the next two factors. You want to factor it by grouping. So this symbol, which is a negative, it comes down as is. And then these two terms have a common factor of 2. So we have a negative 2 times x gives you a negative 2x, and negative 2 times negative 2 gives you a positive 4. Every step of this process, you want to maintain what the original expression is, but we grouped everything together for the sake of factoring. All right, so once you finish up that step, we're basically done. The first factor would be the common factor, which is x minus 2. If these are not common factors, then you want to double check your work because something might have been wrong. And your second factor would be whatever is left over, meaning 3x minus 2. Okay, so, and this would be the factored version of that quadratic that we had at the very beginning. And since factoring is the opposite, the inverse operation of foiling, if you were to FOIL this out, then you will end up getting what we had at the very beginning. Just to demonstrate that, let's FOIL this factored version, which we have x times 3x gives you a 3x squared, and then x times negative 2 gives you a negative 2x. And then let's move on to our second term. We have negative 2 times 3x gives you a negative 6x. And then negative 2 times negative 2 gives you a positive 4. All right, so combine your like terms, which negative 2x minus 6x gives you a negative 8x overall. And then bring down the 4 as is. And this is what we had at the very beginning for the problem. All right, so again, since foiling is the inverse operation of factoring and vice versa, undoing one of them would give you the other form of your quadratic. Okay, so which raises a question that in this step over here, what if you were to flip over the two factors, like as in if I put down the negative 2x first and then your negative 6s as opposed to putting it in the order that we did it in, would it give you the same answer at the end? It should give you the same answer. It's just these numbers are not compatible. And these numbers do have a common factor, but the first two numbers don't have a common factor. But even if you did do it this way, it should give you the same answer at the end. So let's do it. So these two terms have a common factor of, numerically they don't have any common factor, but algebraically they both have at least 1x. And x times 3x gives you a 3x squared, and x times negative 2 gives you a negative 2x. And then bring down your negative symbol as is. And the 6x and 4 have a common factor of 2. So negative 2 times 3x gives you a negative 6x, and negative 2 times negative 2 gives you a positive 4. And again, this is your common factor, so that's your first factor of the quadratic. And the other factor would be whatever's left over, which is x minus 2. And this right here would be the same answer as what we had right over there. Yeah, the factors are flipped over, but that doesn't matter. Think of it as like 7 times 6 would be the same exact answer as 6 times 7. Right? So if you flip over two factors within a product problem, it doesn't matter what order you have. They're both the same answer at the end. So same thing with this. Since both of them are factors, it doesn't matter which order you write them in. They're both the same answer at the end. But again, we should look for compatibility, which is why we chose this way of factoring. So yeah, that's that. Okay, that's number 1. Let's move on to number 2. All right, so for number 2, we're given factor 5x squared plus 19x plus 12. All right, so the first step again would be to get you to satisfy your condition. Two numbers and multiply your AC term, and the AC term in this case would be 5 times 12, which is a 60. At the same time, these two numbers have to add to your B term, which is a 19. Okay, so once you get the two numbers, which should be 15 and 4, think of this step as just a puzzle. You want to think of factors of 60 whose sum or difference would be a 19, and you get them eventually. Once you get them, again, you want to break up the bx term into these two factors. And again, 15 is compatible with 5, and 4 is compatible with 12. So I'm going to put that in that order. We have 5x squared comes down as is, and then the 19x breaks up into 15x's plus 4x's. And then bring down your last term as is, which we have a 12. And that's about it. The second step would be to factor by grouping. The first two terms have a numerical common factor of 5 and an algebraic common factor of x. So 5x times x gives you a 5x squared, and 5x times 3 gives you a 15x. And then bring down the symbol, the plus as is, and then these have a common factor of 4. So 4 times x gives you a 4x, and 4 times 3 gives you a 12. And that's about it. The first factor would be the common factor, which is x plus 3. And the second factor would be whatever is left over, which is a 5x plus 4. And that would be the entirety of the factorization of that quadratic. Okay, that's number 2. Number 3. And these just take more and more practice. As you do more and more of these, you'll get better at the process. All right, so 5x squared minus 18x plus 9. Yep, so we want to get two numbers and multiply your AC term, same condition, which AC in this case would be a 45. And at the same time, the two numbers have to add to your B term, which is in this case negative 18. Yep. And these numbers would be a negative 15 and a negative 3. So let's break it up as such. Again, 15 is compatible with our 5 and 3 is compatible with our 9. So I'll put it in that exact order. We have 5x squared. The first term again comes down as is, but the middle term breaks up into these two factors over here, which we have a negative 15x minus 3x plus 9. Okay, so these two terms have a common factor of 5x, and 5x times x gives you a 5x squared. 5x times negative 3 gives you a negative 15x. Then these two terms have a common factor of negative 3. So negative 3 times x gives you a negative 3x. And negative 3 times negative 3 gives you a positive 9. Be careful, some people just bring down this symbol as is, but that's not always going to work. You want to maintain equality of all your steps. So negative times negative would give you that positive symbol over there. And just be careful that you put the right sign. All right, so the first factor is your common factor, which is an x minus 3. And the other one would be whatever is left over, which we have a 5x minus 3. Okay, and that would be the entirety of the factorization process for number 3. Okay, so we got 2 more left, and let's move down for that. Okay, so number 4. Factor 4x squared minus 15x minus 25. All right, so it doesn't matter how big the numbers get, it's the same condition. You're going to get two numbers and multiply your AC term, which AC in this case would be 4 times negative 25, and that gives you a negative 100. At the same time, these two numbers have to add to your B term, which is a negative 15. All right, so the two numbers whose product would be 100 but whose difference would be a 15 would be 20 and 5. But of course 20 should be negative, because negative times positive gives you an overall negative, and negative 20 plus 5 gives you a negative 15. All right, so the first term comes down as is, and then let's put the 20 first, because 20 is compatible with our 4. We have a negative 20x, and then we have a positive 5x. And then bring down as is your last term, negative 25. And the first two terms have a common factor of 4x. So 4x times x gives you a 4x squared, and 4x times negative 5 gives you a negative 20x. And then these two terms have a common factor of positive 5. All right, so 5 times x gives you a 5x, and 5 times negative 5 gives you a negative 25. And that's it. We have a common factor right here of x minus 5, which is your first factor. And the other one would be whatever is left over, which we have a 4x plus 5 left over. And that would be the factors of our quadratic. All right, so last one, number 5. Factor 16x squared plus 60x minus 100. Right? So whenever you have big numbers, there's one thing that can make everything easier if you can detect it. Always check if all three of your terms have a common factor of any number. In this case, every 16, 60, and 100 would be divisible by 4. So to make the numbers easier to deal with, we can factor out the 4 from every single term. And 4 times 4x squared gives you a 16x squared. 4 times 15x gives you a 60x, and 4 times negative 25 gives you a negative 100. All right, so whatever process we've been doing, the same thing would apply for the inner quadratic. The 4 would come down in every single step. Don't forget about that 4. If you forget to bring down the 4, then you don't maintain equality of your original expression. So make sure that you bring the 4 down every single step. All right, so now again, two numbers and multiply to AC, which in this case AC would be 4 times negative 25, and that's negative 100. And then adds to your B term, which the B term over here would be a positive 15. Very similar to what we had for number 4, right? So the two numbers would be 20 and negative 5. And we can break up the BX term the same way that we did before. So I'll put a bracket here so we can tell what the difference is between our parentheses and our brackets. So the first term comes down as is, and the 15x breaks up into 20x's minus 5x's. Then bring down as is your C term, which is a negative 25. And then the same factorization, factor by grouping process. So the first two terms have a common factor of 4x, which if you take it out, then we're left with the x plus 5. And these two terms have a common factor of -5, so -5 times x and -5 times positive 5, and that'd be it. Again, the 4 comes down as is, and the common factor is x plus 5, so that's your first factor. And the other one would be whatever is left over in the bracket, which we have 4x minus 5. Okay, and that would be the entire factorization of our quadratic. So the point of doing number 5 would be that that if you can see that every term has a common factor that you can take out from every single term, then you should take it out, which makes the inner quadratic have smaller numbers, and that just makes the process a little bit easier to carry out.